Hi students, welcome to our channel JEE Maths by Sensor. Of course you know that myself is Satyanarayana, formerly called as Sensor. Today I am going to teach some models in inverse trigonometric functions. In inverse trigonometric functions, simply called ITF, generally for the mains point of view, the sum to infinite series and finding sum to n terms of the given series is useful for JEE mains and frequently asking the questions from this model. Now let us see the question. Tan inverse 1 by 1 plus 1 plus 1 square, tan inverse 1 by 2 plus 2 square, so on up to n terms. Sometimes they may ask so on up to infinity. How to solve these kind of problems? That means the total summation you just express in terms of one general term. The student should be able to write these all in terms of one general term. That means sigma, I will write this as tan inverse sigma tan inverse, see, 1 by 1 plus r square. The total summation just I have written in general term. Let us take TR, where r running from 1 to n. R running from 1 to n, tan inverse 1 by 1 plus r square. If you see r equal to 1, the first term will get. Of course, sigma stands for summation. If r equal to 2, the second term will get summation plus. If r equal to 3, third term, so on up to n terms. This is a primary step to do. That means to just convert in terms of a general term. After this, we have the two important formulae in ITF, especially in terms of tan. Tan inverse. Let me write the formula for understanding purpose. Tan inverse x plus tan inverse y is equal to, we already know this as tan inverse of x plus y by 1 minus xy, provided x positive, y positive, xy less than 1. Sometimes if it is minus, we get tan inverse of x minus y by 1 plus xy. 1 plus xy. I think this everyone should know this. Now here tan inverse of 1 plus r by r square is there. I write this as r running from 1 to n. Tan inverse of, listen, 1 plus is there. Since 1 plus is there, I write r plus r square as r into r plus 1. The student should get an idea that it is already in the form of 1 plus ab or 1 plus xy. If denominator is in the form of 1 plus xy, then obviously see, I write here 1 plus xy, it will be in the form x minus y. If it is 1 minus xy, the numerator will be x plus y. Of course, tan inverse. Now, since we got 1 plus r into r plus 1, I write this as sigma r running from 1 to n, tan inverse of 1 plus xy. The numerator should be x minus y. What is the x minus y? If you observe, I can write r plus 1 minus r. R gets cancelled, 1 is there. Same. By 1 plus r plus 1 into r. You see, the total sum of the terms are expressed in terms of tan inverse of something. Tan inverse of r plus 1 minus r by 1 plus r plus 1 into r. It is in the form of tan inverse of a minus b by 1 plus ab. We know that sigma r running from 1 to n, this is tan inverse r plus 1 minus tan inverse r. Formula I applied. Tan inverse a minus b by 1 plus ab is tan inverse A minus tan inverse B. After this, You open the sigma, that means keeping the values of r. If you keep 1, r equal to 1, this will be tan inverse 2 minus tan inverse of 1. This is first bracket. If you keep r equal to 2, tan inverse 2, I mean 3 here, here tan inverse of 2, plus, if you keep r equal to 3, we get tan inverse of 4 minus tan inverse of 3, so on. Last, if you keep r equal to n, what we get? Tan inverse of n plus 1 minus tan inverse of n. This is the last bracket. This is the last bracket. Now if you see, this gets cancelled. These two gets cancelled. Similarly, what we get here, the last term will get cancelled. It's an important point here. In the first bracket, if the first term gets cancelled, naturally, in the last bracket, last term will get cancelled. That means if it is last term, here the first term. In some cases, if this is there, then this will be there. Reverse. Now, what is left here? Tan inverse of n plus 1 minus tan inverse of 1. This is n plus 1. Remaining all gets cancelled. This one and this one. Now, we can leave like this. This is the answer. Or still we can simplify. Again in the form of tan inverse A minus tan inverse B. That means what? Tan inverse of A minus B by 1 plus A into B. The answer is tan inverse of n by 1 plus n plus 1. The answer is tan inverse of n by n plus 2. This is the answer. This is a way to do sum to n terms or the sum to infinite terms in terms of infinite, inverse trigonometric functions. Okay? Shall we discuss the other one? Okay. ಅದು ಸೇವ್ ಆಗ ಇದೆ. Yeah, let us go for the next problem, same model. Sigma m running from 1 to n, tan inverse of 2m by m power 4 plus m square plus 2. M power 4 plus m square plus 2. The students, before there is a difference between the before one and this problem. Already general term given. There is already general term given. In the before problem, we have converted into general term. Okay. Now, I told you, tan inverse of something is there. If you see this, we can able to get an idea that expressed in terms of tan inverse of a plus b by 1 minus ab or tan inverse of a minus b by 1 plus ab. Now, you go for the denominator. You see denominator is what? M power 4 plus m square plus 2. Not only in this problem, generally this term, total term will frequently get in mathematics. How to resolve this? how to express in other terms. See, I write this 1 as 1 plus 1. That means m power 4 plus m square plus 1. Just I have written 1, 2 as 1 plus 1. Now, my dear students, for these again I am writing m square as 2m square minus m square plus 1. Nothing wrong. Nothing wrong. Same. 2m square minus m square, m square. Now, 1 plus m power 4 plus 2m square plus 1 minus m square. You just observe this. How I written? I have taken m power 4, 2m square plus 1 as one bracket minus m square. Why I have written 1 plus, I write this as m square plus 1 whole square minus m square. You see? See, from first 2, I have written 1 plus 1. After that, I have written m square as 2m square minus m square. And I have written m power 4, 2m square plus 1 as one bracket. And m square is other term. Since in the form of a square plus 2ab plus b square, a plus b whole square minus m square. Now, this is 1 plus a square minus b square, a plus b into a minus b, m square plus 1 plus m into m square plus 1 minus m. See, finally, the total denominator in this denominator I have expressed in terms of 1 plus AB. 1 plus AB. I told you, if it is in the denominator 1 plus AB, express numerator in terms of A minus B. If denominator in terms of 1 minus AB, for example, here in the form of like 1 plus XY. If it is 1 plus XY, the numerator should be X minus Y. If it is 1 minus XY, then numerator should be X plus Y. Now, come to the question. This is tan inverse sigma m running from 1 to n, tan inverse of the denominator as 1 plus m square plus 1 plus m into m square minus m plus 1. Now, how I write this 2m? Now, come to the numerator 2m. It is in the form of 1 plus xy. It should be what? X minus y. That means this minus this or this minus this. You just convert. I write this as m square plus m plus 1 minus of m square minus m plus 1. Now look at the numerator. M square gets cancelled. M minus of minus m 2m. That is there. 1 minus 1 gets cancelled. Now it is in the form of tan inverse A minus B by 1 plus AB. Now sigma m running from 1 to n, tan inverse A minus tan inverse B. That means tan inverse of m square plus m plus 1 minus tan inverse of m square minus m plus 1. Now applying the sigma, keeping the values of m. If m equal to 1, listen, tan inverse. If m equal to 1 square 1 plus 1, that is 3 minus tan inverse. If m equal to 1, this gets cancelled 1. This is first bracket. Plus, if you go for m equal to 2, tan inverse 2 square 4 plus 2 6 plus 1 7 minus tan inverse m equal to 2 na 2 square 4 minus 2 2 plus 1 3. Okay, enough. Still we can write or enough. Now giving the values n, last value n, tan inverse of n square plus n plus 1 minus tan inverse of n square minus n plus 1. Now again, you see here, these two gets cancelled. I told you in the before problem, whenever the first term gets cancelled in the first bracket, here the last term will get cancelled in the last bracket. Obviously, the last term will get cancelled in the last bracket. Now, what are the left side? This is the first term in the last bracket, and last term in the first bracket is left. Now, that is what? Now, tan inverse of n square plus n plus 1 minus tan inverse 1. We can leave like this, or still we can simplify again in the form of tan inverse A minus tan inverse B. Tan inverse A minus B by 1 plus AB. This is A, this is B. That is n square plus n plus 1 minus 1 by 1 plus n square plus n plus 1 into 1. Now this gets cancelled. The answer is tan inverse of n square plus n by, this is what, n square plus n plus 2. This is the answer. Today I have discussed the two problems, and still I will discuss some more problems up to infinite series also. Right.